Breadboard is a fundamental tool used in electronics and prototyping to build and test circuits without soldering. It provides a convenient way to experiment with different electronic components and connections quickly and easily. Breadboards are widely used by hobbyists, students, and professionals alike to create and test electronic projects. The main features of a typical breadboard include board layout. A standard breadboard consists of a rectangular plastic board with a series of holes arranged in rows and columns. These holes are designed to accept electronic components, such as resistors, capacitors, transistors, and integrated circuits, ICs. Terminal strips. The breadboard has two sets of long horizontal rows at the top and bottom, known as terminal strips. Each row contains multiple interconnected holes, allowing components or wires to be easily inserted and connected along the length of the board. Bus strips. In the center of the breadboard, there are typically two sets of parallel bus strips running vertically. The bus strips are usually used for distributing power and ground connections to different parts of the circuit. Component placement. Breadboards typically have a pattern of holes that correspond to the standard lead spacing of electronic components, such as 0.1 inches, 2.54 millimeters. This allows most through-hole components to fit securely into the breadboard. Contact points. The holes in the breadboard have metal clips or springs inside that grip the component leads, providing electrical connections between components. Reusable. One of the primary advantages of breadboards is that they are reusable. You can quickly rearrange or modify circuits by inserting or removing components without damaging them. To use a breadboard, you insert the leads of electronic components into the appropriate holes to create connections. Wires are then used to bridge the gaps between components and create the desired circuit. The bus strips on the breadboard allow you to provide power and ground connections to all the components on the board without the need for additional wiring. It's important to note that while breadboards are excellent for prototyping and experimenting, they have certain limitations. At higher frequencies or in complex circuits, signal integrity and noise issues may arise due to the inherent capacitance and inductance of the breadboard. In such cases, printed circuit boards, PCBs, are used for more reliable and optimized circuit layouts. Nonetheless, breadboards remain an indispensable tool for learning and testing electronics concepts.